Good day. We are looking at AX5, and that is a parent shape because there's no lone pair on it. When we do this, our example is going to be PCl5, and it's going to be trigonal bipyramidal. Our quality camera person is going to pan up here to the lab assistant who is holding this beastie. Now, when we look at our PCl5, what we have is we have basically a north pole and a south pole. These guys are all in a row, and then around the equator we have our 120 degrees. So it's called bipyramidal because we have a pyramid up top and we have a pyramid below, two pyramids bipyramidal. So if we have all the same atoms on the outside, this thing is going to be a nonpolar beast, a lot of symmetry. Now we are ready to go to AX4E. Our example is TeCl4, and it turns out there's going to be a lone pair left on the tellurium. That lone pair is going to make a big difference, and we're going to end up with a distorted tetrahedral, which is a slimy name. Way better to call it a seesaw. So what we're going to do now is we're going to look at this, and we are going to remove that beast there, and now it's been replaced by a lone pair. Helps to rip off the right one. Yikes. That's what we want to do. We're going to take away from the equator. When we do that, this is our distorted tetrahedral. Do the seesaw action. Now you see what's a seesaw or a teeter-totter. Something they've banned from playgrounds around Hope, apparently. But this minimized the repulsions. It made it so this lone pair is still 120 degrees away from these other bonds, and it's 90 degrees away from there. Our next beast, AX3E2. So we have ClF3, and it's going to end up being T-shaped if we take the right thing off. And now you're going to rotate it there, so now you see it's like a T. And then if we rotate back like this, what's happened is we've taken off two bonds, replaced them with two lone pairs. Again, this minimizes electron-electron repulsions, and we end up with that T-shape. And the last one is AX2E3, so I3 minus, so it just has 1 minus charge, but 3 atoms. And in this case, we've ripped off from the equator again, and you see why it's linear. It's all straight, and it has 3 lone pairs around the equator that minimize the repulsion. We're trying to keep those lone pairs away from each other, and so make sure you understand, if we hit that, it's linear. These guys are all going to be violators because they have 5 pairs of electrons around the central atom. Well, 5 times 2 is 10. That violates the octet rule. Cut.